Alright, so now that we have learned how to augment data, let's actually train a ResNet on augmented data. So first we will train ResNet on a non-augmented dataset as a baseline, and then we will add the data augmentation to see if it makes it better or worse. So it's always a good idea to establish a baseline before we are applying any, let's say, data transformation. This is analogous to what we've done when we worked with learning rate schedulers. Before applying a learning rate scheduler, it's always a good idea to also establish a baseline without a learning rate scheduler. So here our baseline is essentially the network that we had in unit 7.4 without any transformation. So I'm essentially using the exact same code and train this baseline first, and then we will see how we can apply these transformations that we just talked about in the previous video and improve this network with this data transformation. So here, just executing the code. And then we are training the network for 50 epochs, which might take, I would say, 10 to 20 minutes. Of course, in a real world project, you would only do that once, and then for every experiment, you already have this baseline, so you don't have to rerun anything here. I run this here to show you that this is really the baseline performance that we would be getting without any data transformation. Okay, let's take a look at the results. And as we can see, the model overfits quite a lot. So we can see there's a huge gap between the training accuracy and the validation set accuracy. And we reach a test accuracy of almost 82%, 81.6%. So let's now see how our augmented pipeline affects the training performance by implementing our image augmentation and then training the network with the image augmentation. So this is essentially the same notebook, except that I'm going to add the image augmentation to it. So let's add the image augmentation that we developed earlier in the previous video. So we are going to add this maybe below here. So for this, I'm going to first paste the Cypher10 data module here. So notice that we have these two modifications. We have the train transform and the test transform as arguments. So we are saving them here. And then we are going to use them when we instantiate the Cypher10 data set here. So there's a transform argument here for the training one where we pass the train transform. And then for the test one, we pass the test transform here. And so then we are going to use the data loader as usual. So the main modification here really is that we are passing these transformations, which we can then also define up here. So after setting up our data module here, let's now also set up the transforms that we had in the previous notebook. So again, this is essentially the same we had before, where we have the resizing, the random cropping, the random horizontal flip, the random color jitter, and the two tensor transformation, and then the normalization. And then for the test transformations, we don't have any randomness here. So with that, we can then train the model. Notice here we are passing the train transform and the test transform to the Cypher10 data module. But except that, everything is identical to the previous notebook. So let's train this and see what the performance is. Okay, so the results are in. Let's take a look. So we can see the training loss and the validation loss, they are closer together. And we can also see that the validation set accuracy and training set accuracies are closer together now compared to before. So before we had this huge gap between training accuracy and validation accuracy, where we had a validation accuracy of, I would say, 83% and 100% training accuracy. Now we have about, I would say, 87% validation set accuracy and maybe 97% training accuracy. So the training accuracy is slightly reduced, but we get a lot of benefit in terms of the validation set accuracy, and there's of course less overfitting. So now looking at the test set accuracy, we now get almost 90%, whereas before we got 81%. That's almost a 8% performance boost, which is quite nice by just adding a few, let's say, data transformations to our images. So in this video we have learned that data augmentation can be beneficial, and the ResNet performs much better when we train it on the augmented dataset.